Hi ladies, today we're going to talk about rate of change. This is related to slope. We will talk about slope in a couple of lessons, but I'm sure you've heard of that term before. So everything's related. We'll be looking at graphs and finding the rate of change of linear equations based on a graph, and we'll also be looking at tables and finding the rate of change of information given in tables as well. So let's just first start off by defining rate of change. This is a rate that describes how one quantity changes in relation to another quantity. The quantities that we are going to be looking at today will be the change in the vertical position of a point and its horizontal position. So rate of change is equal to the change in vertical position. So the up and down. Again, think of a linear equation, so a line graphed on a coordinate plane, and we want to find the change in the vertical position between a couple of points and the change in the horizontal position. And horizontal goes left to right. So again, this one's up and down, this one's left and right. Okay, and we can say mathematically that I'm looking for the change in y versus the change in x. We can use a little triangle for that. Okay, and what does that mean? Well, think of a linear equation. When graphed, we have a coordinate. It's an xy coordinate, right? So we basically want to find, well, what's the change from one y coordinate to the next? And what's the change from one x coordinate to the next? And that will give us our rate of change. When describing a rate of change, please use units. So when describing, use units. So I want to know, for example, the rate of change might be $10 per hour. Maybe you're babysitting, and if you babysat for 1 hour, you earn $10. For 2 hours, you earn $20. For 3 hours, $30, so on and so forth. I could graph all of those points in the first quadrant of a coordinate plane, and I would get a line. And I could say, the rate of change is $10 per hour. So that's what we're going to be exploring today. Let's see specifically how to do this and how to work with our numbers. So what I would love for you to do is to get out page 25, and let's take a look at number 1, where we are looking at a graph. Look at the units. It's amount of milk and week. So basically, we're amount of milk versus a week. Let's see. What we want to do is pull any 2 points from this graph. So if you notice too, we're looking at liters of milk. That's what the capital L is, just to remind you. And I want to pull any 2 points. Why 2 points? Well, if I have 2 points, I can figure out the change in the vertical position, or y, and the change in the x position. It doesn't matter which 2 points you pull. So pull any 2 points that lie on the line. Don't estimate. Look for points that actually line up with the grid markings. It is much easier that way. The first point I see is 0, 0. It happens to be on the line, so I'm going to use 0, 0. It's a pretty easy point to work with. Also take a look. We could use the point 1, 2 or 2, 4. Okay, I can even go all the way up the graph. I could do 9, 18. Again, it does not matter because we're going to simplify our rate. So whichever 2 points we choose, once simplified, we will all get the same rate. So how do we find the change? Well, the vertical change, for the vertical change, we need to look at y coordinates. I'm just going to look at these first 2 because, again, those numbers are really easy to work with. And to find the change in the vertical position in the numerator, I'm going to subtract. That's how you find the change of something. So I'm actually going to label this x2, y2, and x1, y1, these are just subscripts. They don't represent exponents. They don't mean I'm calculating anything differently. I'm just pointing out that I have two different points here. So to find the change in y, I'm going to subtract my y values, and then to find the change in x, or the change in the horizontal, I'm going to subtract my x values. So again, to calculate rate of change, this is how we could go about doing it. It doesn't matter which point you label x2, y2, or which one you label x1, y1, as long as you're just consistent and you start with the same point on top and bottom first. So let me find my change in vertical. That would be 2 minus 0. And then my change in horizontal would be 1 minus 0. This works out really nicely, 2 over 1. So that's my rate of change. But remember, I need to have units. So let's look back at the graph. The y-axis has a label, and that's the label that we're going to use for our vertical change. So 2 liters of milk per 1 what? Per 1 week. So maybe your family goes through 2 liters of milk a week. So we can explain it. 2 liters of milk per week. Okay? You can write it like this. If you wanted to keep it like this, that would be fine with me as well, as long as you have the labels in there. Let's go ahead and take a look at another example. In number 2 on the same page, we are given a table. So you don't have to graph these points to get the straight line. We are told in the directions that we have linear functions here. So these tables do represent lines. So they give us an XY table. Something to point out is that even if the X and Y aren't there, so here we have year and we have salary over Y, X is usually typically on the left and Y is typically on the right. That is not always 100% true, but most of the time it is. So if there is not an X and Y present, please just know that the left column will represent the year and the right column, left will represent X, which might be the year, and the right column will represent Y. We're going to do the same thing to find the rate of change. We want to find the change in our vertical or Y position and our change in X or horizontal position from one point to the next. So again, we can choose any 2 points. This time, I could choose 1 and 21,000, but let's say you chose the last 2. So let's say we had 3, 26,000. So that would be our first point, and maybe the second point is 4, 28,500. So I'll label the first one x1, y1, and my second point x2, y2, and let me go ahead and subtract my y values on top and my x values on bottom. Again, just make sure that you're being consistent and that you stick with the same point starting each time. So 28,500, that's my y2, minus my y1, 26,000, all over, let me start with x2 again, 4 minus 3. This works out well. We get 2,500 over 1. So let's take a look at our labels. Well, the Y represents a salary or money, so $2,500 per 1 what? Per 1 year. So that is the rate of change, $2,500 a year. Both of the examples we just looked at represented increases. So when you have a positive rate of change, it represents an increase. So you probably know what I'm going to say next. If you have a negative rate of change, it represents a decrease. Just looking at number 3 on page 25, you can see that the line is going down and to the right. It's a negative trend, so that's going to be representing a decrease. I'm not going to go through that one right now, okay, but we'll do more examples like those in class. So let's go ahead and move on to a little bit more application. This is an example that I'm just going to talk about, so you can just take notes. It's not on any of your handouts. So A CD spins at different speeds when playing songs on the inside tracks, which is near the center of your CD. Okay, so inside tracks would be here. Then when playing songs on the outside tracks, as shown in the table. What table? Well, let me just jot it down for you. So here we have number of seconds, and that would represent X. And here we're talking number of revolutions of the CD, Y. And I'm going to split it up a little bit differently here. I'm going to have inside tracks, and I'm going to have outside tracks. Just want you getting used to this type of table. So, 0 seconds for 0 tracks. But it will take 2 seconds for 16 here and 6 here. Let me add one more level to this. So 4 seconds. It will be 32 revolutions for the inside tracks and 12 revolutions for the outside tracks. Okay, so my question is, what happens when we compare these rates of change? Do they have the same rate of change or do they not? Well, we already said that the CD spins faster for the inside tracks than it does for the outside tracks. So most likely the rates of change are not the same. So how do we set this up? Well, in order to compare the rates of change, we need to first look at the number of seconds versus the inside tracks. And then we're going to compare the number of seconds versus the outside tracks. So it's almost as if we have 2 tables in one. So this will be one ordered pair, but then I'm going to take this 0 and this 0 for my second ordered pair. What else do I have? I have 2, 16, but I also have 2, 6. We're just sharing the X, the number of seconds. My last coordinate would be 4, 32, or for the outside tracks it would be 4, 12. So I just needed to point that out to you because you may have to compare different rates of change and you might be given a table such as this. So to find the rate of change again, you just need 2 points. I'm going to stick with the one involving 0 because I feel like that's easier. I'm going to do 16 minus 0 for my Y change, 2 minus 0 for my X. That's 16 over 2, which is 8 over 1. And again, let's go back to our units. That's 8 seconds per... Oops, I just wrote that incorrectly because our seconds is for our X value. And remember, Y is the vertical change. So it is 8 revolutions per 1 second for our inside tracks. So it's spinning 8 times every second. Here for our number of seconds with the outside track revolutions, we have 6 minus 0 over 2 minus 0. That gives us 6 over 2, which is 3 over 1. And again, with our outside tracks, we're talking revolutions here. We have 3 revolutions for our outside tracks per second in this case. And again, this just shows that a CD spins at a faster rate when playing songs on the inside track than when playing songs on the outside tracks. If we were to graph these, we would see that a rate of change 8 revolutions per second would give us a much steeper line than 3 revolutions per second. So that would be a steeper line. Okay, I think there's only one other piece I'd like to touch on before class. Just a quick concept summary of the rate of change, just in general. And I'm going to sketch a couple of graphs here. Okay, when you have something like this, it is a positive rate of change, and it represents an increase. That makes sense. Okay, if it is something like this, that is a negative rate of change, and that represents decrease. Something we're going to talk about more in class tomorrow is no change at all. 0. No change. And that's when we're given a horizontal line. So we'll explore more of that in class. I will see you then. Thank you very much.